Hello, I welcome you to this interesting discussion where we are going to look at how we can make our chemistry simplified. In this discussion, we're going to talk about the atomic structure. Well, one thing that I want to take you through, you have to remember that everything that we have in this life is really built up of atoms. So atoms are the building blocks for everything we have in our life. If you look at salt, salts are solids. The common salt is the sodium chloride. You can say having atoms of sodium and chlorine, NaCl, sodium chloride. Then you can have solids of, say, sugar. Sugar is also a bit of atoms of carbon, hydrogen, and oxygen. Water, the liquids, molecules, atoms of hydrogen and oxygen. Eventually, somebody can call it H2O, as we have also talked about NaCl. Oxygen is a gas. So if you look at water, look at the atoms, the molecules here. They're not so much spaced as you saw in the solids where the particles are closely packed together. In gases, the particles are a little bit far apart. But those, for example, if you look at gases, if you look at oxygen, assuming this bottle is having oxygen, the atoms are a little bit far apart. You find millions and millions of atoms in the solids. If you look at the paper, this paper, just only the thickness, we have millions and millions of atoms from the paper. These atoms are the smallest particle of an element that can take part in a chemical reaction. But in the atoms, you have also particles, subatomic particles. You can talk about the particles we call the neutrons, the protons, and the electrons. At the center of the atom, we have what we call the nucleus. See, it is at the center of the atom, and then you have the electrons. The electrons are going to be found at the shells. If you look at the shells are the energy levels. So they're surrounding the nucleus. In the nucleus, you have the protons, which are positively charged, and then the neutrons, which are neutral. As you see, they carry no charge. So the electrons are moving around they are just moving around the shell, and for them they are negatively charged. So they try to spin around the nucleus at different energy levels. You find that as they spin, I'm trying to show you how they spin around the nucleus. So you find that for them, they are going to be negatively charged. And because for them, they're negatively charged and the protons are positively charged, you find that they must have the same numbers. The number of the protons and the neutrons are always going to be the same. That leaving the atom neutral. You see that? So these energy levels around the nucleus are going to be of different size. You find the first energy level around which is closest to the nucleus, the K. The first energy level is K, and it can carry a maximum of 2 electrons. Then the next energy level, which is L, can carry up to 8 electrons. And then it follows. We have talked about KLM, and then finally N, which is a little bit far away from the nucleus. So that is the first energy level, which is K, then L, the second energy level, M, and then we move on to the one which is a little bit far away from the nucleus. But you find that we have talked about the first carrying a maximum of 2 and the next carrying a maximum of 8. Now look at some of the definitions of the terms they're using. If you talk about a proton, the protons you have said they occur are within the nucleus and they have a unit mass, each carrying over positive charge. The atomic number will be giving you the total number of protons in the nucleus of an atom or an element. All the atoms of the same element will have the same atomic number. You see that? So this atomic number is unique for every element. And it will be used to identify the element. Then the neutrons are also in the nucleus, but for them we say they carry no charge. And they also have a unit mass. They're always approximately the same number as the protons. When you sum up the protons and the neutrons, you get what we call the mass number or the atomic mass. Then we can look at other terms like electrons. Electrons occur in the energy levels or in the electron shells, and they're constantly rotating, as we saw in the figure that I just put on the screen previously. The mass is about 1 out of 1,840 of the proton, and that is a little bit negligible, but they carry a negative charge. You have to remember that the number of electrons with a negative charge, the energy levels, are equal to the number of protons with a positive charge in the nucleus. Thus, you find that the atoms are going to be always neutral. Now, the mass and atomic number. What you call the atomic number, symbolized by Z, that the total number of protons in the nucleus of an atom, of an element. Atoms are neutral since we have said the protons are equal to the number of the electrons. So you know the positive charge is balancing the negative charge. The mass number or atomic mass is the sum of the neutrons and the protons in the nucleus of an atom, of an element. Protons and neutrons occupy the nucleus. That's referred to as nucleons. So if somebody is telling you to find the nucleons, still asking to find the mass number. Because now the mass number or the nucleon number is the total sum of the protons and the neutrons in the nucleus. So you can always use that as a simple addition. You can always have the notation or the denotation as the X, or you can give it a letter, but to symbolize the atomic symbol. And then above here, you can put the mass number, and below, you're always having the atomic number. So that you can use that symbol to illustrate mass number and the proton number or atomic number. Electronic arrangement. Arrangement of electrons in an atom is referred to as electron configuration. So when somebody talks about electron configuration, try to look at the arrangement of the electrons in the shell, in the shells of the atom. Electron structure now is the diagram you draw showing the distribution of electrons in the energy levels. So we are going to try to look at some illustrations of that later on. What rules can we use in writing electron configuration or drawing the structure? The first is that the first electron shell, the one nearest the nucleus, is filled first before you can go to another energy level, because this is our first, the lowest energy level for the K. We call it the K. And then the second, before you go to the second, that shell will have a maximum of 2. We talked about that one. And you try to look at that as, we call it the duplet. And then the second energy level, which we talked about as now the L. can carry maximum of 8. These ones are outer shells. Even L, M, all those ones will carry maximum of 8. They can't exceed 8, though they can have less than 8. But when they fill up the 8, we call that one the octet. So we can have some of the elements here. The first 10 elements, we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So you can see hydrogen will have 1. So it is only filling the K, that's the first electron near the nucleus. And then 2. This one now is complete, it's a duplet. So it's helium. And then lithium is having 2 complete. Now it goes to the second energy level. And then beryllium, 2 complete, then you fill in 2. This one means 1, 2, 3, 4. So that's now the atomic number. And it gives you the number of electrons that are in the shells. Gives you the atomic number. Then you go to boron, fills 2, it goes on to the next, which is 3. Then you go to carbon, fills 2, then goes on to 4. Then nitrogen fills 2, then goes into 5. Then oxygen fills 2, then goes into 6. Fluorine fills 2, goes into 7. Then neon fills 2, goes into 8, which means the second energy level is complete because it's having 8 electrons. Now, when you look at the first 20 elements in the periodic table, the periodic table will be arranged in such a way that it has, shall see the periodic table later on in our lessons, but you can have those elements, as you see, their energy levels. This one has it has only 1 energy level, even with helium. Then go to lithium, 2 energy levels, like that, as you've seen. So we shall have a detail of that in our discussions, but that's just a sample showing you how the periodic table is arranged. These are the first 20 elements and the way they fill the shells. So you have the K, here it has 1, then K has 2, K has 2, then it goes to L, that is 2, 1, that's now lithium. KL 2, 3, 2, 2, that's boron, beryllium, then boron 2, 3, then we have like that. So you have energy levels being filled like that. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, like that. So we shall look at a detail of that, but I just wanted to show you how the energy levels are filled, and then you can try to do the structures. Then you come up with the configuration, which is now here. It's 1, 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, according to the way the electrons are being occupying the shells. Then we have a concept of isotopy and isotopes. An isotope or isotopes are atoms of the same element with the same atomic number of protons but different mass numbers or neutrons. Then isotope is the existence of atoms of the same element with the same number of protons but different neutron numbers. So we have some good examples here. Like if you look at chlorine, chlorine has isotopes. You can see here the mass is 35, but here the mass is 37, which means the protons are 17, the same proton numbers, but different neutron numbers. Here they are 18, here they are 20. So giving a different mass. And you can see the arrangement of the electrons in the shells. Then you can also have another example, which is hydrogen. Hydrogen, there's hydrogen with mass number 1, then mass number 2, mass number 3. The different names, protium, then deuterium, and tritium. So those ones are different examples that we can have. So you can use this idea to do a quiz, which you try in your free time. If you have the atoms here, electrons, protons, neutrons, and they're giving you A, B, C, D. Electrons, 8. Protons are 8. Neutrons are 8. If somebody asks you the mass number, you can get it. Something B, C, also giving you that. Somebody can use that to calculate the value of X. in those questions. Then you can also use them to get the ideas of variance, as we shall see in the periodic table. In our next discussion, we can use the small quiz to try and really get the value of x, and then the approximate relative atomic mass. We shall look at those ideas in the next discussion. So thank you very much. We can meet for another lesson and shall build on that to look at the periodic table. We are going to look at the relative atomic mass and then what we call the periodic table and how they are arranged. And you further on look at the electron configuration and also look at those charges. How can you get the charge of such atoms? So thank you very much. Don't forget to subscribe to this channel and get more ideas in simplifying chemistry. Thank you. My name is Raj. Let us meet for other discussions.